All right, so today is our last sort of combined section of DAT OAT prep. We're talking about the math that comes on the DAT and the OAT. And then next week we'll split up a little bit. One will go physics for the OAT and the other will go perceptual ability test for the DAT. So without further ado, let's look at the math that we're going to see on something like this test. So in both cases, the math comes last, which I think makes it a little bit harder for folks because you're a little bit burned out at that point. You're running out of energy. So it behooves you to really understand the kinds of questions and ways to speed yourself up for this section that you may not have to worry about for the other sections. You do get a calculator, but is a calculator of limited function. It would be a, it basically just does plus, minus, multiply, divide, and negative sign. Outside of that, it doesn't do any other functions. There's no powers, no square roots, none of those other types of things that you would normally expect to be associated with a calculator. So very minimal function. Basically, you need to consider your calculator as only a tool for doing arithmetic. So you got to find other ways like deal with powers and square roots and things like that. Things that are covered on here are going to be algebra, all the expected things from algebra, data analysis, basically getting data from a table or a figure, data sufficiency questions, which are a special type of question we'll look at an example of today, quantitative comparison, which is a special questions type that we'll see today, as well as probability and statistics. Notice no geometry, no pre-calc, no trigonometry. This is basically high school or below math that they expect you to know, which is why I think people struggle with a little bit, because it's things you haven't done in a long time, like solving systems of equations, figuring out probabilities, figuring out combinations and permutations and things like that. Plus they present a lot of word problems, so you have to get good at parsing those out. So one of the things we can do is stop doing algebra. That's going to help make this test easier overall. And there's a couple techniques. Have any of you guys actually taken a ACT or SAT prep course in the past? So you might not then have run into this technique, and it's what's called plugging in. And there's a couple different ways plugging in can be used to make your life easier. The first one of those is when you have, like in your question stem like this, we have variables in the question and we have variables in the answers. Rather than doing the algebra, which runs the risk of, number one, forgetting how to do the algebra, and number two, having difficult time because you're rushing and you're missing things like distributing negative signs, which would be the case in this problem, then there's an easier way to do it. We can just pick numbers for the variables and plug them into both the question stem and the answers. So, and that's when you see variables in the question stem and variables in the answers. So one of the things you can do is just choose values and stick with positive values of integers that are greater than 1. So the reason why 0 and 1 and negatives are bad, because 0 makes things disappear, 1 makes things stay the same, and negatives can get even more confusing than it already was. So stick to like 2 and up integer values. So for this question, I just chose x equals 4, y equals 3, and c equals 2. I'm going to take those values and I'm going to plug them into that equation. So if I plug in x equals 4, y equals 3, and c equals 2 into A, what do I get? And this is where the calculator comes in handy, because you can just use it to do these straight away. So what would I get for A? I would agree, I'm going to get 9. So A is going to be 9. All right. What would I get for B if I plug in 4, 3, and 2 for X, Y, and Z respectively? I'm going to get 1. So again, I'm just using my calculator to do arithmetic, and boom. And then what's my A minus B, which is the target that we're looking for? That should be 8. And what I'm going to do is on my scratch paper, I'm actually going to circle that number, because whatever my answer is, it should be equal to 8. Now we're going to go back and we're going to look at each of the answer choices. So if I look at answer choice A, what am I going to get for answer choice A if I plug in 3 for Y? Is it going to equal 8? Does answer choice A give me 8? Nope. So get rid of that answer. Does answer choice B give me 8? Nope. Just get rid of the answer. And so on and so forth. The 0 is definitely not 8. D gives me 6, positive 6, still not that answer. And E is the only one that gives me 8, and therefore that must be my correct answer. And this always works. Whenever you've got a scenario where you have variables in the questions and variables in the answers, you could always choose numbers, smartly choose numbers, because like 0 and 1 are going to make multiple answers correct. But if you use a good set of numbers, you're going to find that only one of the 5 answers actually gives you that same result. So this is what we call plugging in the variables. It's going to streamline what you do. And you might be looking at this now going like, this is going to take me longer. But trust me, when I see students staring at an algebra problem for a while, going to themselves like, wait a minute, man, I forgot how to do this. That right there, that time of trying to figure out how to do it, even though you know how, it probably is going to take you just as much time, if not longer, to approach the question than if you just jump right into it, only do arithmetic, and solve the problem this way. So plugging in is your friend. Try to use it as much as possible. And there's another version of the plugging in question. Here I have numbers in my answers, and I have a variable or variables in my question. What variables are actually in this question, by the way? There's none explicitly given, but what things in this question are variables? And this is the nature of word problems you got to get used to. Number of binder clips, specifically the number of 14-cent and the number of 16-cent binder clips. So they didn't give you a letter, they just gave you some unknown, and those things are the variables. So here we have a trigger that says I got variables in the question and question stem, I have numbers in the answers. This should tell me something that I can solve this question a different way. I can plug in the answers. If I start with the answers and work my way backwards, this becomes a much simpler question. It's like doing a maze in reverse. So if I start with answer choice C, that tells me I've got 30 14-cent binder clips. So how much do those 14-cent binder clips cost? How much does 30 14-cent binder clips cost? $4.20. Where does that 55 come from? It comes from the fact that I have a total of 85 binder clips, which means I must have 55 16-cent binder clips. So how much did those cost? That's $8.80 for a grand total of $13. Is that matching the total that was given in the question? No, so I know the answer can't be 30. Is it too big or too small? It's too small, which means, do I need to have more 14-cent clips or more 16-cent clips? This added up to less than the total amount. Do I need more of the cheaper or more of the more expensive clips to get to a higher amount? I need more of the more expensive. So which other two answer choices can't be it? We could just, this point can eliminate two additional answer choices. No, not A and B, because what are these answers? They're the number of how many, of what type of clip? They're the number of 14-cent clips. You just told me I need more 16-cent clips. So do I want a bigger or smaller number of 14-cent clips? I want a smaller number of 14-cent clips, which means D and E are also incorrect. All right, then once we've done that, we can move up or down appropriately. So we just now know we're gonna move up to 25. So 25 of the 14-cent clips gives us $3.50. It gives us 60 clips that are 16 cents, which is $9.60. Does this answer choice work? Yeah, it does, because that adds up to $13.10, meaning B must be the correct answer. I don't have to check A. If this didn't work, if it wasn't $13.10, what would the answer have been? If it wasn't B, it would have to be answer choice A, because we have no other choices. A must be the only one to work. And you could just answer based on that. You don't actually have to do the work. Plugging in the answers is, again, it's a way to avoid, in this question, setting up a system of two equations and two unknowns. That's the way that technically they want you to do it. Doing like F plus S equals 85, and then F times 4.14 plus S times 0.16 equals 1310. Like, that's what they want you to do, but you don't have to actually do it. You can walk through doing the arithmetic without doing the algebra. So I would encourage you all to try doing this plugging in technique as much as possible, because it really does save you a lot of time and make sure you're not making some silly mistakes in the process. And time is of the essence on this test. Now, the first of the unique style questions that you might not have run into before, so a good chance you probably haven't, are the quantitative comparison questions. Quantitative comparison questions always have the same four answer choices. Quantity A is greater, quantity B is greater, quantities A and B are equal, and cannot be determined. And cannot be determined is right about 25% of the time on these questions. So normally your temptation is to cross out cannot be determined, but here this is a very viable answer choice. And many of these quantitative comparison questions require you to do trial and error. So you might have to try 3 scenarios to get to the final result. And even if it's 3 scenarios, you might feel like, I still don't know for sure, but you got to cut yourself off at a certain point. If you keep running scenarios over and over and over and over and over and over again, you're never going to actually answer the question, which you eventually need to do. So let's look at an example of what these look like. They usually give you some kind of blurb, something to read that explains the situation, and then they give you 2 quantities. So we've got our first quantity A, which is the extra credit value from picking the first option. What is the first option? Student's average individual score. What is the second option? The median. Okay. So to do this, we have to have a set of 10 test scores. So what I usually do is I say, okay, here's scenario 1. What did the kid get on the 10 different scores on the first one? And there's a smart way to do this and there's a complicated way to do this. The smart way is just stick with something simple. So if you give the student the same score every single time, which is what do you guys want it to be? How many points did he earn on each question if it's all the same? $10? Okay, so we got 10 points on all 10 questions. 10, of course you said 10, so I have to write more. 10, 10, 10, 10, that's all right. 10, 10, 10, 10, 10. And I want you guys to do this. I want you to do this on your scratch paper. So what is the average score if they're all 10s? We can figure that out pretty readily. A is going to be 10. What is the median score? So I go halfway in the middle, 1, 2, 3, 4, 5. My number's in between here, 1, 2, 3, 4, 5. So what's my median? It's also 10. So right now, we've shown that A equals B. But here's why you have to do scenarios. And again, let's be smart about this. Let's just change one of the grades. Or one of the questions. Which question do you want to change? Okay, so we got 0 on the first one, and then 10, 10, 10, 10, 10, 10, 10, 10, 10. Okay, what's the average now? So I'm gonna have 90 divided by 10, which is gonna be 9. So my average is 9. What's my median? That's gonna still be 10 because it's still the middle number. So 1, 2, 3, so it's between these two 10s. So it's still gonna be 10. Now we see that B is greater than A. So what's my answer here? Remember what the 4 different answer choices are. A is greater, B is greater, A is equal to B, cannot be determined. So what answer choice must I have to pick on this one? And it's not that, because only in one of the scenarios was B greater than A. In another scenario, B was equal to A. So if the two scenarios are inconsistent, then what must the answer be? Oops, wrong way. If the results are inconsistent, the answer must be cannot be determined. Because depending on the scenario that I pick, there's going to be different results. I could find a situation where A is greater than B. I can find a situation where B is greater than A, and I can find a situation where A is equal to B. And so that's what I mean that these questions require trials, because the first scenario you pick might say one thing, but the second scenario you pick might say a different thing. And the second that your results differ, the answer becomes D, cannot be determined. And that happens more often than you might imagine. It's not always a clear-cut case that one is bigger than the other or they're equal to each other. In fact, that's only true about 75% of the time. So does everybody understand how these questions work? So most of the time, you're gonna have to run at least a couple scenarios to make a decision. It's pretty hard sometimes just to look at them and go, it depends, or it's always this. So take the time, run one, but no more than 3 scenarios. 1 to 3 scenarios is all you should ever be doing. If you find the same result 3 times, pick that answer. If you find that the results differ, jump to cannot be determined and go on with your happy little lives. All right. There's another weird, this was honestly weirder type of question. This is called data sufficiency. Again, they always have the same 4 or 5 answers in this case. Statement 1 alone is sufficient. Statement 2 is alone is sufficient. Both together are sufficient. Each statement alone is sufficient, and statement 1 and 2 together are not sufficient. So they're basically saying, they're asking you to prove something and giving you pieces of evidence. So I use what's called the ADBCE technique. First, I look at statement 1. If statement 1 on its own is sufficient, then I'm going to narrow myself down to A and D. If statement 1 is not sufficient, then I'm going to narrow myself down to B, C, E. Then I've got to check my second statement and then pick my final answer. So you got to do this in pieces. So let's work through this one. Consider a parallelogram with a perimeter 36. What is the area? If I know a parallelogram, I'm going to draw a picture, has a perimeter of 36. That means I know all its sides add up to 36. So L plus H plus H equals 36. So 2L plus 2H equals 36. Looking at statement 1, is this going to give me enough information to solve this problem, to find out what the area is, if I know that one side is twice as long as the other side? I could say L is equal to 2H. So would that allow me to find the length and the height? I could find my dimensions. I could find L and H. Is that a sufficient amount of information to find sort of H prime here, which is what I would need to solve this question? Because the area is going to be equal to A times L H prime. That is the worst drawing ever. So knowing L and H, would I be able to find H prime? Do you know 2 sides of this triangle, or do you know a side and an angle of this triangle? I know a side, I know the right angle, I would have to know one other angle. So it turns out this is not sufficient. I have to know at least one other angle to be able to solve that, don't I? So not sufficient, which means which answer choice is what I get rid of? not C. Remember, we're looking at statement 1 right now. Statement 1 by itself is not sufficient. If statement 1 is not sufficient, then what answer choices do I get rid of? A and D. So now I'm down. Statement 1 alone is not good enough, and each statement alone is sufficient, because that is the worst line ever. But D is also not true, because 1 alone is not sufficient. So are these weird questions? Oh yeah, they are funky. All right. Now, if I tell you that this angle is 80, say, but now we have to isolate our knowledge, because that's all 2 tells us, is that one of those angles is 80 degrees. With this information and this information, do I know enough to be able to determine the area? Gotta be careful here, because I think what you're doing is you're letting the fact that 1 gives us enough information to do it. But now, if we think about it, I don't know H anymore. I don't know H at this point. I can't know it, because I don't have the information for 1 yet. So now I have an angle, but no length. So 2 alone, is 2 alone sufficient? No, 2 alone is insufficient. So now if 2 alone is insufficient, we can get rid of this answer. And we got to ask ourselves that last question. If I have both pieces of information, could I figure it out? If I knew 1 and 2 together, is that sufficient to solve this problem? Now I know L and H, and I know the angle, which allows me to get H prime. Now I have enough to solve the question. So that means our answer is going to be C for this one. Both statements together are sufficient. So wow, those are kind of funky questions, aren't they? And it's going to take some practice to get used to how these questions work. In fact, at some point, you really just want to have it ingrained in your head what the answer choices are, so you don't have to constantly be thinking back, what is this answer choice? What does it mean? You want to just get into a groove with a pattern on how to solve these things. So that being said, you have to make sure your practice materials include both quantitative comparison and data sufficiency questions in it. Most of them do. Currently, the Princeton Review book does not. So that's why I've given you guys that sort of caveat in the past, that Princeton Review materials, they're not up to date with this. They changed the test back in 2015 to have these types of questions on it. So you need to make sure that whatever you're studying from has data sufficiency and quantitative comparison questions, because it's the math is not the hard part. It's the structure of the question that's the hard part. They're like giving you these weird structures and you're like, I don't know what to do with this. These are on a GMAT. That's where they come from, these types of questions. Why they're using them on the DAT and the OAT, I have no idea. So everybody's kind of, I know you might not feel comfortable solving them, but you guys understand the type of solution you have to set up for yourself on these kinds of questions. And it's okay if you say no. I can go through another example at the end if we need to. Yes, no? No answers? Okay, we'll do one more at the end. That way we make sure we have enough time to get through the other things in here. So I'll do that right at the end. They're weird, I know. They're just freaky questions. All right, sometimes we get stuck with not understanding how to get started on questions. And that's where things like ratio boxes and average pies and stuff come into play. So when you're faced with a question like this, how do you get started? This is saying we've got this ratio and we have 20 pounds in the mixture. How am I going to do this? And this is where people tend to get really, really bogged down because you don't have a starting point. I'll tell you the starting point. Just draw yourself what I call a ratio table. So my ratio table is going to have just my labels. And notice all the things in there: flour, yeast, eggs, yeast, and salt, all start with a different letter. That's pretty normal for them to do. So you can just label them with the first letter, and then you got a total. And you got your ratio row, your multiplier row, and your actual row. And what are they giving me in the question? Well, they've given me the ratio 11 to 9 to 3 to 2. They've given me 20 pounds of the mixture total. So start filling in what you can figure out. So what can I find out in this? Like, anytime you have a row or a column with one empty box, you can always fill in the rest. So what row or column can I currently fill out and finish? Yeah, the total ratio. So what is that going to add up to? $25. Okay, but by doing that, all of a sudden, I have another row or column I can solve. What row or column can I figure out now? I can figure out the multiplier total, because, and what it literally means is ratio times multiplier equals actual. That's how we're setting up this table. Ratio times multiplier equals actual. So what times 25 equals 20? Four-fifths. That's right. So 4/5 can fit in that multiplier row. The nice thing about the multiplier row, when you find the multiplier, is it different or is it going to be the same for each and every one of these things? It's always got to be the same. It can't change. So the multiplier is always 4/5. So now I can find my answer, can't I? Because we're being asked for how many pounds of yeast are there? So what math do I need to do to get my pounds of yeast? Three times 4/5 equals, and what is that going to equal? 12/5. Or if I turn it into mixed number form, 2 2/5, making my answer choice D. So what a ratio box is a thing called a graphic organizer. It helps us just organize our thinking so that we can not have to figure everything out. So, and remember, the rule of the ratio box is if you have a row or column with one missing box, can you finish off that row or that column? If you have a row or column with one missing box, can you finish that row off? Yes, you can. That's why we use these. It's kind of like doing a Sudoku puzzle. It's great when you only have one box left because then you're like, oh, I got the last number. Yay. Average questions also kind of give people fits and starts. How many see a clear path to the answer for this one right off the bat? I'm going to take that as probably no. There's a way, again, to organize your thinking for these. We call that the average pie. Sum the number and the average. Sum divided by the number of things is what? The average. Sum divided by the average is what? The number of things, and the number of things times the average is what? That's the sum. So it's basically putting these things in a nice organized fashion so we know how they relate together. So just start by putting in what you know. So I'm going to draw an average pie with what I know for that first average, which is I have 7 numbers and they average 9, which means what else can I find from that? I can find the sum. What is the sum? I have no idea how sum and song are coming out the same. Then draw another one. For the second average, it's 3 is the number of numbers, 5 is the average. So what can I find from that? $15. Now, if I'm doing math, can I subtract sums from each other? The sum of some digits minus the sum of some digits. Could I do that? Is that okay? Yeah. Can I subtract the number of objects from each other? 100%. Can I subtract averages from each other? Can you do that kind of arithmetic with averages? Do they work nicely that way? No, you cannot. And that's what gets people stuck on these. But I can subtract the 2 pies from each other and get a new pie that says, what's my new value up top? And what's my new value for the sum? So what's 63 minus 15? 48. And what's 7 minus 3? 4. So the numbers that are left over have a sum of 48 and there's 4 numbers left over, which means what's my average? It's 12. And there's my final answer. So what does this trigger for you that like you couldn't have just thought of on your own? What most people want to do is subtract the average from each other because that's what's given in the question. But you actually can't do that. You have to remember that you can get this other thing, the sum, and the sum works that way. The sum and the number of values work that way, but averages don't. So we're like kind of sidestepping the way they set up the question. And it turns out rates work very much the same. Rate questions. Because the amount of work done divided by time equals what? Work divided by time is rate. Well, in this case, that might be what it is. It's velocity or rate. Work divided by rate is time, and time times rate is the amount of work being done. So it has like basically the same setup as the average relationship. So let's do a rate pie for this thing. Our rate pie is just going to be 20 envelopes in 4 minutes. And I can find my rate here. What was my rate? 5 envelopes per minute. So now we need these machines working simultaneously to stamp 60 envelopes per minute. So what do I need to multiply that rate by to get to 60 envelopes per minute? So 5 times 5 is 60. I think you guys are looking at the wrong number. That was 20 envelopes in 4 minutes. This is envelopes per 1 minute. If you look at the question stem carefully, they're saying, I need to stamp 60 envelopes per minute. Are we multiplying the rate or the work here? Which one are we multiplying to get to 60 envelopes per minute? We got to multiply the rate by something to get to 60 envelopes per minute. So what does the rate have to be multiplied by to get to 60? We got to multiply it by 12. That's right. And now that's my answer, because if I know the rate is 5 and I multiply it by 12, the rate is now going to be 60 envelopes per minute. I don't need to know anything else because that's just what the question's looking for. So it's just ways to organize your thinking to make it a little bit simpler to get started on the question. It's all about just getting that foothold into the question. It's all you need, that little start. Now, permutations and combinations, I'm going to just touch on this technique to deal with these kinds of questions shortly. So there's 2 kinds of questions you can be asked. How many ways can Alice, Bob, Charlize, and Devin and Eunice, 5 people, all starting with different letters, by the way, earn first, second, and third place, earning these medals respectively? Versus how many different ways can can these 5 people be the first 3 people to win a race? Are these the same question? They're actually not. Which one's going to be a bigger value? Which one's going to be a bigger number? The first question or the second question? Which one's going to be bigger? Actually the first, and that's a little bit hard to catch. Does the order matter in the first one? Does the order in which they come into place matter? It does, because first is distinctly different than second is distinctly different than third. So the order matters here for this one. Does the order matter for the second one? It doesn't, because it just said for them to come in the first 3 people. So it doesn't matter who's first, second, or third. So the one where the order doesn't matter is going to have fewer results. And that plays out in how we solve this, because the top of this problem looks very much the same. How many different people can come in first place? Five different people. How many people can come in first place? Not just one, because each of them has a chance to come in first place. So 5. It gets more limited as you go, though. How many people now could possibly be second place? Now only 4 of them. How many people could possibly be coming in third? 3. And that is the exact same setup we have over here. 5, 4, 3. Because 5 of them could come in first, 4 second, 3 third. Now the difference is over here, that's it. That's the whole problem. 5 times 4 times 3. Which means how many ways can these people come in first, second, and third? 60. But over here, we actually are going to divide by the particular place, but divide by the number of slots. When the order doesn't matter, you divide out the number of slots, because what we have to do is we have to divide out the number of redundant features. So if it's ABC, or it's AB or CAB or BCA or BAC, those are literally all the same as far as this question is concerned. So we're just taking those out of consideration. So we just divide by the slot that we're trying to figure out, or trying to put these people into, and we just go 1, 2, 3. So how many people, or how many different combinations would we have over here? 3 cancels 3, 2 cancels with the 4 and gives us 2. So how many possible choices? Now only 10. And that's what we should see with these. When the order matters, you should have a bigger answer. When the order doesn't matter, you should have a smaller answer. This is a lot easier than trying to remember that formula NPR and NCR. I don't know if you guys remember that, but that's like how you were taught to do this way back in middle school, or maybe 9th grade or 10th grade. So when the order does matter, you don't divide, and it's a permutations question. When the order doesn't matter, you do divide, it's a combinations question. And then finally, probability problems. Probability is just the number of desired outcomes divided by total number of possible outcomes, which combinations, permutations sometimes comes into play in this total possible outcomes. Sometimes you have to do that here. So here's an example of what is the probability of drawing no aces when drawing without replacement 4 cards from a standard fair deck of cards. No aces. So when drawing the first card, what's the probability of drawing no aces? So how many cards are there? How many possibilities are there? 52. And to draw no aces, that means I got to take 13 out of my 52, which means how many choices do I have? Would it be 40? Wait, not 13. Where did I get 13 out of there? There's only 4 aces in a deck. So if I'm doing no aces, it's 52 minus 4. 52 minus 4, which is what? $48 cards are no aces. Our 48 cards are everything but aces. Agree? Yes, no? Yeah, I was thinking of a suit as well. We're just talking aces here. So there's 4 less cards because of the no aces part. Then for my second card, notice we're doing without replacement. How many cards are left? $51. And how many non-aces are left? 47. And then so on and so forth. So my third no ace would be 46 over 50, and then 45 over 49. So this is a big, ugly number. But the point of this one is the next question. What is the probability of drawing at least 1 ace when drawing without replacement 4 cards from a standard fair deck of cards? Drawing no aces is the opposite of drawing at least 1 ace, is it not? So rather than trying to figure out drawing at least 1 ace, which is actually a complicated question, because you'd have to figure out drawing one ace, then you'd have to figure out drawing two aces, then you'd have to figure out drawing three aces, then you'd also have to figure out drawing four aces. Do you want to do all of those probability problems? Probably not. What could you do? One minus all of that. Because if I draw at least one ace, it's the opposite of drawing no aces. So this is what we call the complement of an event. And so they do this on the DAT and the OAT, where they're going to flip-flop it so that you have to deal with complements. So watch out for that little trick. And then the last little probability trick is this. If it's an and question, which is what we just had, it's multiplication. If it's an or question, it's addition. But then there's the weird or question, which is not being mutually exclusive, which is add and then minus the multiplication of it. This one is the hardest. What is the difference in these two scenarios? What is the probability of drawing a 1 or a 2? Could you possibly draw a card that is both a 1 and a 2? Is there a way to draw a single card that is both a 1 and a 2? Nah, not in any normal deck of cards. So the probability of doing this is going to be 4 out of 52 plus 4 out of 52. In the second scenario, what is the probability of drawing a 1 or a red card? Is there a chance that I draw a single card that is both red and a 1? Yes, there is. So in this scenario, I have to go 4 out of 52 for the 1. For the red card, 13 out of 52. And if you recognize it, this is just the and situation. So you don't actually have to do multiplication here. How many cards are both red and 1 that we're going to subtract out of here? How many red 1s are there in a deck of cards? I'm gonna have you guys counting cards yet. Yep, 2. There's 2 red 1s in a full deck of cards. So here's my answer. It's gonna be 4 plus 13 minus 2, or 17 minus 2, or 15 out of 52. 15 out of 52 is my probability of drawing a 1 or a red card. So this is the weird case where the things are not mutually exclusive. They can both exist. So you got to watch for that in your probability problems as well. Whew. There's some funky math on this test. Now, again, is this hard math? I don't think you're going to find, once you remember the math, that the math itself is hard. I think what you're going to find is that the like how you're going to approach the problems and understand the word problems is the issue here. And that's usually what happens to people. They get stuck on the definitions of things, and just like, God, it's been forever since I've learned this, and so you get really caught up in that. So that's where you just have to be a little bit careful on this test, is just do a lot of practice on different styles of math problems. So I know we went a little over, and one of you guys wanted me to look at another data sufficiency question. I'll do that right now. And so thank you all for coming. Let me get up an example of a data sufficiency question here, which I can run over with you guys if you so choose to stay and listen. Where is it? Where are my data sufficiency questions? Here we go. I've got some data sufficiencies here. So I'm going to change where I'm sharing. New share. That page. Okay, so number 6 here. So we're looking to say, okay, the numbers A, B, and C are all non-zero integers. Is A greater than 0? So is 1 sufficient to tell me whether A is greater than 0? If A is equal to B squared, is that sufficient to tell me that A is greater than 0? Think of some examples. Try some B's out. If B is 0, what's A? If B is equal to 0, then what's B squared? It's 0. So using that, does that tell us A or 1 is sufficient or insufficient to tell us whether A is greater than 0? That is not sufficient. In fact, it tells me that it sometimes is, it's sometimes not, just on this fact alone, because it says greater than 0, not greater than or equal to 0. So 1 is insufficient alone, which means we can eliminate A and D, because 1 is not sufficient alone. How about 2? Is 2 alone enough to tell me this? So if C is equal to 0, then A square root of C is going to be equal to what? If C is equal to 0, then square root of C is going to be what? What is the square root of 0? It's going to be 0. So is that sufficient to tell us if A is going to be greater than 0? No, because in fact, I found an example where it says it's oh crap, noodle boodles. What did I do that was weird? What did I forget to do in my question? Did anybody notice it? And this is the thing about these questions. You have to be very careful in reading them. What did I do wrong? They need to be non-zero integers. Oopsie, back to the drawing board. Sorry about that. So the lesson learned here is make sure to read the questions very carefully. So if B is 1, then what is B squared? 1. And I'm going to do my due diligence here. If B is -1, what is B squared? It's also 1. Now, is this sufficient? Is 1 now sufficient to tell me A has got to be greater than 0? Yes, it is sufficient to tell me this scenario, which means I actually get rid of B, C, and D, or sorry, B, C, and E. Boom, boom, boom. So this is going to say that 1 alone is sufficient, or 1 and 2 together are both, or 1 and 2 individually are both sufficient. Then I come over here and I say, okay, if C is equal to 1, then the square root of C is going to equal what? What's the square root of 1? 1. So that looks like it works. Let's do due diligence here. If C is -1, then square root of C is what? What do you get when you do the square root of -1? An imaginary number. Is that a so that means A is equal to I. Is that a non-zero integer? No. So it violates the rules. So therefore, this case is irrelevant because it violates the rules. So what do we know now? Is 2 sufficient alone to prove that A is greater than 0? But it is, because C equals I, like saying A equals I means that the numbers are not all non-zero integers. So this is a moot point. This one cannot work because it gives me a non-zero integer for one of the values. So we have to disregard it. So 2 alone is actually sufficient. So making our answer actually answer choice D, because that's individually alone, they are both sufficient. So they're tricky, and you got to know your number theory. Like what they're testing you on a lot with these questions is number theory. So you got to know what integers are, what it means to be imaginary versus rational versus all that kind of fun stuff. So it's some really basic math you haven't touched since like a really long time ago. That's the sucky part. So practice, practice, practice. Does it at least show the process a little bit better? Unfortunately, I apologize for screwing up at first, but I think it was a good lesson to be learned that you got to make sure to read the question stem. So the math, there's so many little strategies that you can do, and you really are trying to avoid doing math for the most part. You just got to learn how the questions work and kind of, in essence, kind of cheat. It's not really cheating, but it's like it's being smart in how you solve the problems.